The Earth's crust contains many compounds. But the compounds themselves aren't as useful to us as the elements they're made up of. This rock contains aluminium oxide. Split the aluminium from the oxygen and you have one of the world's most useful metals. You can split a compound using electricity. The idea is to pass an electric current through it, a process known as electrolysis. A circuit is set up using 2 carbon electrodes, an ammeter, and a power supply. The white powder is lead bromide. Switch on the power supply, and nothing happens. The ammeter reads 0. Solid lead bromide doesn't conduct electricity. It needs to be molten. Lead bromide melts at 370 degrees Celsius. Switch on now, and a current flows. In this circuit, the electrode on the right is positive, the one on the left is negative. As electricity passes through the molten lead bromide, chemical reactions start. On the left, at the negative electrode, nothing appears to be happening. But at the positive, bubbles mean a gas is being produced. Placing small tubes around the electrodes traps any gas, making it easier to see their colour. What could the brown gas be? The gas is bromine. Although nothing obvious appears to be happening at the left-hand electrode, pouring the molten lead bromide away reveals a small silvery metallic bead. This is pure lead. So, passing an electric current through molten lead bromide breaks it down into the elements lead and bromine. To work out why this happens, imagine you can see the charged particles, the ions, in the compound. There are positive lead ions and negative bromide ions. Once the power supply is switched on, the lead ions are attracted to the negative electrode. The bromide ions are attracted to the positive electrode. Lead ions pick up electrons. They lose their positive charge and form lead atoms. Bromide ions give up electrons. They lose their negative charge and become bromine atoms. These form a gas. Electrolysis of lead bromide only works when the compound is molten. Why doesn't it work when the compound is solid? Change the compound from lead bromide to zinc chloride and the products of electrolysis will be different. What would you expect to see happening when electricity is passed through molten zinc chloride? This time, bubbles of a very pale gas appear at the positive electrode. It turns damp blue litmus paper red and bleaches it lighter. So what gas is it likely to be? Again, nothing appears to be happening at the negative electrode on the left. But pouring off the molten zinc chloride reveals a bead of pure zinc. In industry, electrolysis is carried out on a huge scale. Massive amounts of electricity are used to extract reactive metals, like aluminium, from their ore.